All right, so in this video, we're going to identify trigonometric parts of a triangle and then use trigonometry to solve missing measures. So first thing, what are the trigonometric parts of a right triangle? All right, there's going to be four parts that we have to be concerned about. First part is reference angle. All right, so it's the non-right angle, meaning it's not 90 degrees in a right triangle. It's usually denoted with an uppercase letter or Greek letters. Greek letters that are pretty common that you're going to see would be theta, or phi, so be aware about that. And don't be surprised by that notation. That's just what we usually use for reference angles in trigonometry. The hypotenuse, remember, is the longest side of a triangle, always opposite the right angle, right? The next two parts you guys are going to be a little familiar with. You know what legs are, okay? But now we're going to talk about the adjacent and opposite, right? Now we might be talking about to what? And that is the reference angle, right? So the adjacent leg is the side that is the leg that is a side of the reference angle. The opposite leg is the leg that is not a side of the reference angle. So when I take a look at this particular picture here, right, we immediately know where and what is the hypotenuse, right? We can identify that pretty quickly. Now in this particular picture, we do have a label here of theta. So that's going to be our reference angle. So this is our reference angle. That leaves then our two legs here, right? Now, it's important to know where the reference angle is because then we can figure out what's the opposite leg and what's the adjacent leg. So I'll emphasize with a highlighter what is the reference angle. So that's these two sides of the triangle, right? So one side of it is the hypotenuse, and the highlighted side that we have here, this leg, highlighted leg, that would be the adjacent leg. Then that leaves that third side for us to be the opposite leg. It's going to be important to be able to label these because then you're going to be able to solve. So let's take a look at some examples, see if we are familiar enough with it. So again, I take a look here. I immediately identify where's the right angle because that tells me right away where's the hypotenuse. You may abbreviate, that's okay. I'm also going to label now our reference angle. And again, if it helps you see, here's the reference angle. You can see it, one side is the hypotenuse, the other side is a leg, and that would be our adjacent leg then. That leaves the remaining side, our opposite leg. So now we have our triangle labeled. Let's take a look at this next one. So same thing, I identify right away where's that right angle. That tells me where the hypotenuse is. We know where our reference angle is. That's this theta. And again, I'll highlight one more time. Right, this is what our reference angle is. Right, one side is the hypotenuse, the other side is a leg. That would be our adjacent leg then. The remaining leg then is our opposite leg. All right. So that's how we label the trigonometric parts of a right triangle. In this next part, we're going to use what we call the trigonometric functions to help us solve for missing measures. So I've got a triangle here, and I'm going to label it with the trigonometric parts. Now, of course, theta is our reference angle, but I'm not going to write that in here, right? But I will highlight it orange. So we have three trigonometric functions. Their names are sine, cosine, and tangent. They're abbreviated as sin, cos, and tan. You may have seen those buttons on any kind of scientific calculator. Usually it's what, if your calculator can perform these types of functions, that's what makes it a scientific calculator. And so each one has a specific definition. It really is an equation. So I'll write out what those are, and it utilizes this triangle here. So these are the three basic trigonometric functions or formulas, right? If you notice, right, they're really just proportions. And be aware about how I've used color here to identify each of the parts. Now, how do we utilize that to then solve missing measures? All right, we have three steps that we need to address. All right, step one, right, label the trigonometric parts of the right triangle. Step two, you're going to need to set up all the trigonometric ratios. Ratios are same thing as these equations, right? So I should really add in. And then step three, we're going to solve. Okay? So, problem number one. Step one, we want to label all the trigonometric parts of this triangle. So we've got my hypotenuse. We've got theta. That's going to be our 61 here, which then tells us where our adjacent leg is. And our opposite leg. Now, there's no easy way right away to pick out which ratio it will be. Practice will get you there. But if you don't know, you should write out all three. When you do, it usually becomes apparent as to which one we will use to solve. So I have all three written out. Now I just need to substitute the values in. So remember, our goal is to solve for x here. Taking a look at these three equations, which ones have x? Right? We can see that this one does, and so does this one. So we immediately know this is not going to be the one we want to use to solve. Now, comparing these two, right? This cosine equation does not has it has x, but it also does not know what the hypotenuse is. So we can't solve that one. This one's useless to us. Tangent works for us because it's the only value that's unknown is the x value. So this is what we can solve. So this is the problem I'm going to solve. I'm going to treat this like a proportion. So I'm going to make the tangent a fraction over 1, and now I'm going to cross multiply. So 1 times 22, and tangent of 61 times x. Now I'm going to solve for x here. I'm going to show you what I'm going to do on this next step. We're dividing by the tangent of 61 to get x by itself. So then our answer is 22 over the tangent of 61 equals x. Now, obviously, this answer probably won't make much sense. We need to give it a real number answer. So we're going to have to take out our calculator and always make sure that we're in degree mode down here where angle is. So we are in degree mode. So we are okay. All right. So now 22 divide tangent of 61. Don't forget to close your parentheses. We end up with, and oftentimes you're not going to see a pattern with these decimals. And I highly recommend to go to 4 decimal places. So final answer, x is about 12.1948. Let's go to the next example. So same situation. Step 1, we're going to want to label this triangle. So again, if you don't know, I highly recommend writing out all 3. Substitute what you do know. So again, our goal for this particular problem is to solve for x. So we notice that cosine here doesn't have x in it, so I immediately know that one's not appropriate for us. Sine does have x, but we don't know what the hypotenuse is. Not useful for us. So that again leaves us with tangent as the only solution here for us to work out. So go ahead, cross multiply, and solve. Now, x, you'll notice, is completely by itself. So I can go straight to the calculator here. Do the product. We end up with x equals 19.2733. Okay. So our last example here. Let's take a look. We're going to do the same thing again. Label our triangle. Now, in this particular problem, right, we have a missing angle. So this angle is going to be our theta, or our reference angle. And we'll continue to label the triangle accordingly. And again, if you don't pick up immediately which one we're going to use, sine, cosine, or tangent, again, what you're going to want to do is write out all 3. Okay, so you can see I abbreviated leg opposite with OPP because I don't know what that is. Now, you might be like, wait a second, all 3 of these have A in them. All right, you are correct in that. But which one is going to help us solve for A? A has to be the only missing piece. And so when I take a look at sine, sine has A missing, but it also has the opposite leg. So it's not going to help us here. Cosine does have our missing angle and nothing else. So it looks like cosine is going to be our choice. Now, just to go over, tangent, you'll see has a missing angle, but it also has the opposite leg missing. That's why we don't want to use that one. So in this case, the problem to solve here is the cosine problem. Now, we have to be extra careful when we're solving for angles here. Our goal is to undo the function. In order to undo the function, we have to use what we call the arc function. So what does that look like? To undo it, we would apply what's called the arc, or sometimes we say cosine inverse or inverse function. It looks like this. Let's see if I can get a right pen here. So that's what we're going to apply to both sides. What that allows us to do then is it frees A away from cosine. All right, so then we're just left over with A. And then on the other side, we have cosine inverse of 6/10. All right, now obviously, again, that doesn't give us a real number that we can measure from. So we're going to go back to our calculator. You're going to use cosine, but we're not going to use COS. We got to use the arc cosine. So that's going to be hitting the shift button. So we got to hit the second shift key, cosine. You'll see now that the arc symbol, right, the -1 exponent comes up. Now I can type in my fraction, and that will tell us what the angle measure is. And as always, go to 4 decimal places, unless otherwise stated. So 53.1301 is our angle. So that completes our lesson here. If you have any questions, please let me know or give them to your teacher. Take care.